Good morning, everyone. So here in this video, we are going to demonstrate the advantage of semantic chunking in advanced RAG pipeline. So as you all know, what is chunking? Chunking basically in RAG pipeline, when user upload any document or any kind of text, we need to create a small chunks of that entire text to store that chunks into the vector database. So later, when user ask any question with respect to that information, we can refer a very related document chunk to pass this information to the large language model to get the answer. So now let's understand what is the advantage to integrate semantic chunking or any kind of advanced chunking. So in regular, we are mainly using a fixed size chunking, or we might use a recursive character text splitter of a line chain. But the problem in this kind of legacy chunking is it can create a chunk with irrelevant information. So let's say, for example, here in this example, if we have this large document, if we use a recursive character text splitter or a fixed size chunking, this is an example of fixed size chunking, we might end up having two different chunk with irrelevant information. So here you can see few information of the first set of paragraph might be included into second chunks. So this is a very simple example, but in real life scenario, or in we can say in real use case, we might end up having a irrelevant chunk in the RAG pipeline. So how we can resolve this? So to resolve this, we are having a very advanced chunking process which is called as semantic chunking. As you can see, this is an output of semantic chunking. So in semantic chunking, we basically pass through entire document. We group, or we can split this document into the different sentence. For each sentences, we are creating an embedding of each sentence, and after creating an embedding, we are evaluating a cosine similarity between the two sentences. And if these two sentences are very much similar, then we can create a chunk with a very related or very near cosine similarity score. So by that, we are end up having this kind of chunks, which having a single chunk with a very limited information. Now let's dive into how you can implement a semantic chunking into the RAG pipeline. If you are using Python with LangChain, LangChain already has a class called semantic chunker, by which you can do semantic chunking by using that class. So you just need to create an instance of this class using this OpenAI embedding or any embedding and pass the document. It will create a semantic chunking out of that. But if you are using a LangChain with JavaScript, LangChain yet not released the semantic chunker class for JavaScript library. So we need to implement by our own with respect to the semantic chunking architecture. Dive into the actual implementation of semantic chunker. So this entire implementation is done in TypeScript. So I created the semantic chunker class, and in the semantic chunker class, we are having one public method, which is named as create document. So you can use that create document. I will publish this code and will share the link in the description or in any other form. So you can directly use this create document method to get the semantic chunks. But let me explain what the actual implementation or what are the steps that it follow to make the semantic chunking. So here in this method, you need to pass the document you can pass multiple document. So here the first step would be it will extract a text and metadata for each document, and we loop through the each text of the each document. So once we having entire text of a single document, we basically split this entire text into the different sentence. So we can process on that. Once we have a different sentence of an entire text, we basically structure the sentence. So here in this method, we are having a common structure, so that you can see this interface. So this interface is basically we are integrating to make it unified, because we take the each sentence and create an object of each sentence of this form. So the purpose of to create the object of each sentence is later on it will pass through a different method to create a chunk. So it is a kind of to make it unified across different method, we are making a unique object for each sentence. So let me go back to the method. So the purpose of this method is to create that object, sentence object of each sentence. So here you can see it could be the output of this method. It will contains a sentence. So from the entire text, if it has a sentence 1, sentence 2, and sentence 3, we would be having this three different object like this. It contains an actual sentence. Combined sentence means the actual sentence and the next subsequent sentence. So it will combine that to later on to create an embedding and get a cosine distance between two sentences. Let me go back to this actual implementation. So once we have an array of an object of sentence object class or interface, the next step would be the generate an embedding of each sentence. So here in this method, we would traverse through every sentence and create an embedding. Let me go back over here, and here you can see it traverses through each and every sentence and create an embedding of combined sentence. Let me go back here. After creating an embedding of each sentence, it create a cosine distance and significant shift. Let me go back over here. And here you can see once we have an embedding of each sentence, we basically figure out a cosine distance between the two sentences. Based on that, we can create a chunk. So here we are having this as an output. And finally, once we have an embedding and we calculate a cosine distance between the sentence, we group the sentence which has a very near cosine distance, or based on that we create a chunk. So in this entire implementation, we break this entire text of document into the different sentence. We create an embedding of each sentence, combined sentence. We calculate a cosine distance between a sentence, so we can figure out whether these two sentences are very much related to each other or not. We create a chunk for the sentence which are very related to that, so we can have a different chunk, each having a very related information. Now let's check semantic chunking in action. I have integrated the semantic chunking class into my own product ChatGuru. So as you can see in ChatGuru, we can use the semantic chunking and we'll check live in action. So let me upload one document so we can check that into the console. So let me upload the document now. I'm going to upload my own resume. And once I will create a bot, it will fetch all the text and create a semantic chunk. So we can see the chunks into the console log. So here you can see it create a different chunk from over here. This is chunk 1. So it groups the information into the related information and it created a different chunk. As you can see over here, it's created a very meaningful and related chunks. Thanks for watching this video until end. If you are still struggling to get a very accurate, related, and very truthful answer into the RAG pipeline, head over to the ChatGuru, create your AI bot, and get a very accurate and precise chatbot, AI chatbot, and you can embed the same high quality chatbot into your website as well.